Hello coders, I welcome you all. In this video, we are going to discuss a very important concept in natural language processing called n-grams, also called as bag of n-grams. We will cover both the theory with practical examples so you can understand it clearly. Now, when we work with the text data, it is not like working with a regular data set. As you can see here, for example, in a house price prediction problem, we already have proper features like the number of rooms, area, and the age of the house in years. Such features are directly available in the dataset. It's very easy to use these features with different machine learning models, right? But in NLP, it is totally different. Here, we mostly get raw sentences that you can see on the screen. Sample IMDb movie reviews dataset. And here you can see review text. So as I said, in NLP, we are mostly get raw sentences, plain English text. There are no direct features available. So now what can we do? We have to generate features from the text itself, and n-grams help us extract those features from plain English text. Bag of n-gram is called as n-gram feature selection as well. Now let's understand what n-grams actually are. So as you can see in this particular table, our first column, n-gram type, second, n value, third, what it means, and example tokens from this particular sentence. I love NLP. So in n-grams, when n is equal to 1, we called it a unigram. That means we are taking one word at a time from the given sentence to form a unigram. As you can see, this is our sentence, I love NLP. And from this particular sentence, we are taking one word at a time. That you can see, I love NLP. In n-grams, when n is equal to 2, we call it a bigram. That means we are taking two words at a time from the sentence to form a bigram. As you can see, from this particular sentence, we are taking two words at a time to form a bigram. Now, in n-grams, when n is equal to 3, it's a trigram. That means we are taking three words at a time to form a trigram. That you can see here. From our sentence, we are taking three words at a time, form a trigram. So as you can see, by increasing the value of n, we can incorporate large context that you can see here. However, if we further increases the value of n, that also increases the sparsity. Means most of the values in the vector will be 0, right? Now, as you can see here, we can even mix them as well. Here you can see unigram plus bigram. Also, we can mix unigram plus bigram plus trigram to capture both the individual words and short phrases for better context. That you can see here. The combination of unigram and bigram. That you can see here. Unigram and bigram from this particular given sentence. Don't you worry. We will discuss this all unigram, bigram, trigram, and combination of this unigram and bigram with practical examples. So let's start with the most basic type of n-gram, unigram. Here in unigram, we take one word at a time from the sentence to form a unigram. No combinations, no pairs, just break the sentence into individual words. So please remember, during different examples, here we are not removing stop words. Now let's take two simple example sentences. First one, this laptop is good. And second one, this laptop is not good. As you can see, first sentence is positive, while next sentence is negative. Now, if we apply unigram, we split them like this. You can see unigram for sentence 1 and unigram for our sentence 2. This laptop is not good. As we discussed earlier, in unigram, we are taking one word at a time from the sentence to form a unigram. That you can see here. Unigram for our sentence 1 and unigram for our sentence 2. From both sentences, we collect the unique words, and that becomes our vocabulary, meaning the features generated by unigrams. That you can see here. This is our vocabulary. Here we have collected all the unique words from both the sentences. Now let's create bag of words matrix, means bag of unigram. This means we go sentence by sentence and count how many times each word from the vocabulary appears. That you can see. This is our bag of words matrix, means bag of unigram matrix. Now the question is why we are creating these vectors from the given sentences, right? So we create these vectors to convert sentences into numbers. So the machines can compare sentences in a mathematical way, check how similar two sentences are, and understand some basic meaning from the words called semantic meaning. Think of each sentence as a point in space. And as you know, vectors can have many dimensions. Here you can see, here we have 5 dimensions. But to keep it simple, let's imagine them in 2D space. So here, let's create x-axis and here y-axis. 2D space. And here our 2 vectors. So if 2 vectors means sentences are closer to each other, small angle like this means they are similar. If the angle is large like this, they are not similar, right? So this way we can use vectors to identify semantic meaning among sentences. So now let's move on. Let's back to our bag of words matrix. So now you can see what's happening here. In sentence 1, all words are present except not. So it gets 0. In sentence 2, not is present. So it gets a 1. Now if we look carefully, 2 vectors are almost the same. Only one word, not, is different, that you can see here. But as humans, we can clearly understand good is positive, not good is negative. But the machine doesn't see this because Unigram doesn't understand the connection between words. It just treats each word individually, not as a part of a phrase. I hope all of you are clear with Unigram. We are taking one word at a time from the sentence to form a Unigram. I hope all of you are clear with Unigram. For better understanding, let's discuss Unigram practically. After that, we will discuss Bigram, Trigram, and combination of Unigram plus Bigram. So now let's move to Jupyter Notebook. So now first from sklearn.feature_extraction.text, we have to import count vectorizer. Also from sklearn.matrix.pairwise, let's import cosine_similarity. Also let's import pandas as PD. Let's execute this cell. Let's create our documents. Our first document, this laptop is good. Our second document, this laptop is not good. Now let's create instance of count vectorizer. Let's assign it to one variable vec. Now let's check the parameters of count vectorizer. So here there are many parameters, but currently we are interested in this particular parameter. Let's copy this and let's paste it over here. This particular parameter is ngram_range, which is already set to 1, 1, which is default Unigram. Means we are taking one word at a time from the sentence, no pair, no combinations, just single words. So here in count vectorizer, default is Unigram. Let's execute this cell. Done. Now let's take this particular instance of count vectorizer and fit_transform. And here let's pass our documents. Let's assign it to one variable x. Let's execute this cell. Done. Print x, and it's a sparse matrix, right? So we have to convert into 2 arrays. Execute this cell. You can see our bag of words matrix for Unigram. Before we move forward, let's check vocabulary using this parameter of count vectorizer. Let's execute this cell, and here you can see these 4. Laptop 2 is 1, good 0, not 3. It shows unique word found in the text. This is our vocabulary. Actually, these are the features used in the bag of words. And here you can see these numbers 4, 2, 1, 0, 3 are just column positions in the matrix. Our bag of words matrix. So good is in column 0, is in column 1, and so on, right? Hope all of you are clear with vocabulary and how we can check our vocabulary. Now let's move on. Now let's create data frame so we can visualize it in a better way. So for that, let's use pandas data frame, and here we are passing x to array. Let's execute this cell. You can see 0, 1, 2, 3, and 4, but actually we require different features like this. For that, we have to use this method using count vectorizer object. Let's execute this cell, this one. Now let's copy this and the pandas data frame. Let's set this as a column names. Let's execute this cell. Done. You can see this is our bag of words matrix for Unigram. Let's assign it to one variable df. Let's check df. Done. Now let's check cosine similarity between these two vectors. So what is cosine similarity? Cosine similarity checks how similar two vectors are by measuring the angle between them. It gives a value between 1 and 0. 1 means very similar. Angle is small. 0 means not similar at all. Angle is 90 degree, right? So now let's check cosine similarity between these two vectors. And as you know, we have already imported this from sklearn.matrix.pairwise. We have imported cosine similarity. Let's copy this. Let's paste it over here. Here we have to pass x0 and x1. Actually this one, right? x0, which is pointing to this particular vector, and x1 pointing to this particular vector. Let's execute this cell. It is showing array, but we are interested just in this particular number. Here 0 and again index 0. Great. You can see. So in our case, we get around 0.89, which is very high. But as you can see, these two sentences mean very different things. This laptop is good, is positive. This laptop is not good, which is negative. Yes, the model treats them almost the same, that you can see. But Unigram doesn't understand that, not changes the meaning of good. That's the key limitation of using Unigrams. They don't capture word order or context, just individual word presence, right? Hope all of you are clear with this, right? Now let's back to our presentation. So here you can see some of the advantages of using Unigram. It's very simple to implement and computationally efficient. It works well for basic text analysis tasks where word presence alone is useful. It generates a smaller feature space which helps with model training time and memory. Now here are some limitations of Unigram. It fails to capture the relationship between words. I know you must be knowing this, right? It cannot identify phrases or multiple expressions like not good in our case. It ignores the order of words, which can lead to misinterpretation of meaning. I hope all of you are clear with this advantages and limitations of Unigrams. Now you might be thinking, if Unigrams don't understand meaning, are they even useful? The answer is yes, absolutely. Unigrams are still used in many real-world applications where just checking the presence or frequency of words is enough. Some common applications include spam detection, topic classification, basic sentiment analysis, search engines, word clouds, keyword extractions, and many. I hope all of you are clear with Unigrams. Now let's move to bigrams. Now we have seen how Unigram works. Let's move to the next level, bigram. Here we take two words at a time, like small phrases. This helps the model understand word combinations and gives better context. Here we are using same two example sentences again. Our first sentence, this laptop is good. Second sentence, this laptop is not good. Now if we apply bigram, we split the sentences like this. As we discussed earlier, we are taking two words at a time from the sentence to form a bigram. And you can see bigram for our sentence 1 like this. This laptop is and is good. Now you can see bigram for our sentence 2. This laptop is not good. So this way we can create bigrams that you can see here. Bigrams for our sentence 1 and bigrams for our sentence 2. Now from both sentences we collect all unique bigrams to form our vocabulary, meaning the features generated after bigrams that you can see here, our vocabulary. So here we have collected all unique bigrams from our previous two sentences that you can see. This laptop is good, is not good. Now let's create the bag of words matrix, bag of bigram, also called as bag of 2 gram. Like we can say for Unigram, bag of 1 gram. Same here, we can say bag of bigram, bag of 2 gram that you can see here, bag of 2 gram or bag of bigram, our bag of words matrix for bigram. Now you can see in our sentence 1, this laptop is good, right? In our sentence 2, we still have this laptop is that you can see here. But now we also get is not and not good in our sentence 2. Notice how is not and not good show up only in our sentence 2. This time the model can see that not is a part of a phrase, not just a single word. This gives a better understanding of the meaning in context. I hope all of you are clear with bigram, where we are taking two words at a time from the sentence to form a bigram that you can see here. Before we move forward, let me show you how we can implement bigram using Python and sklearn. Let's move back to Jupyter Notebook. As you can see, we are using same code as we have used for Unigram, and this is our cosine similarity for Unigram. It here Unigram, copy this and let's paste it over here. Same way we will find for bigram, also for trigram, and for mixture as well of Unigram plus bigram, right? So as I just said, we are using exactly the same code as we have used for Unigram. Just we have to change this particular parameter for bigram. Let's change it to 2, and here is also 2. Let's execute this cell and let's execute all the cells up to end. And here you can see this time for bigram, this is our cosine similarity. Let's copy and paste it over here in our table. But as you can see, the cosine similarity for bigram is very much lower than with Unigram, that you can see here, because now the model realizes these sentences are not the same. Using bigrams, we have added more dissimilarity between the two sentences, and that's actually what we want, right? Based on their meanings, right? One is positive and another one is negative. So we want dissimilarity, and that we have introduced here using bigram. And also, if you see here, more words are different now, like is not and not good, which only appear in sentence 2. This helps the model understand that these two sentences are not saying the same thing. So you can see more words are different now in our bag of words matrix, means in our bag of 2 gram, like is not and not good, which only appear in sentence 2. This helps the model understand that these two sentences are not saying the same thing. Hope all of you are clear with bigram, where we are taking two words at a time to form a bigram that you can see here. It is working fine, right? Actually better than Unigram. Now let's move on. After Unigram and bigram, the next step is Trigram, which means taking 3 words at a time. This gives better context and helps the model understand long phrases more clearly. Now let's back to our presentation. So before we move to Trigram, here are some advantages of using bigram. It captures phrases and context. I'm sure you must be knowing this, right? It helps with things like not good versus good. Here are some limitations of bigram. Vocabulary size increases and still misses meaning if important words are far apart, like 3 or 4 words away. Now let's move to trigram, where we are taking 3 words at a time to form a trigram. Let's take the same 2 sentences again. This laptop is good and this laptop is not good. Now if we apply trigram, we split the sentences like this. As we discussed earlier, we are taking 3 words at a time from the sentence to form a trigram, and this is trigram for our sentence 1. This laptop is and laptop is good, and this is trigram for our sentence 2. This laptop is not good, right? So here trigrams for our sentence 1 and sentence 2. From both the sentences, we collect all unique trigrams to form our vocabulary. And this is our vocabulary, collection of unique trigrams from our previous 2 sentences. Now, as usual, we apply the bag of words matrix. Here, bag of 3 grams, also called as bag of trigram. This means we go sentence by sentence and count how many times each trigram appears. Now, this is our bag of 3 gram matrix. So now, if we observe this in sentence 1, we have trigrams like this laptop is good. In sentence 2, we still have this laptop is, but now we also get laptop is not good. Notice how laptop is not and is not good appear only in sentence 2. So now the model understands longer phrases, not just one or two words. This helps the model capture more context and meaning from the sentence. Hope all of you are clear with trigram, where we are taking three words from the sentence to form a trigram that you can see here, right? Before we move on to mixed n-grams, let me show you how to implement trigram using Python and sklearn. Now let's move back to Jupyter Notebook. Again, we are using exactly the same code that we have used for Unigram and Bigram. Again, we are interested in this particular parameter only, and gram underscore range. Just here we have to change 3, 3 to form a trigram. Let's execute all the cells up to end. Oh great, you can see here the cosine similarity is very lower as compared to Unigram and Bigram. 0.40. Let's copy and paste it over here. Because now the model can spot more differences between two sentences that you can see here. Trigrams like laptop is not and is not good appear only in sentence 2. So the model understands that the two sentences are not saying the same thing at all, that you can see. So this way we can use Unigram, Bigram and Trigram as per our requirement. Now let's move on and let's combine Unigram plus Bigram based off both words. Let's move back to our presentation. Now before we move forward to Unigram plus Bigram, let's discuss some advantages of using Trigram. So as you know, it provides better context compared to Unigram and Bigram. I'm sure now you must be knowing this. It captures full phrases and more precise meaning, and it is very effective when word order plays an important role in the sentence. And here are some limitations of Trigram. It requires a large dataset to see repeated trigrams. I'm sure now you must be knowing this, right? Because here we are combining three words at a time. So requires a larger dataset to see repeated trigrams. It may not perform well if the dataset is too small or limited. And when used with bag of words, it can create a very sparse matrix. Most values are 0, which makes models slower and heavier if we are using trigram. Right? I hope all of you are clear with trigram and advantages and limitations of trigram. Now let's move on. Now let's discuss based off both together, Unigram plus Bigram. As we have seen how Unigram is simple but misses context, and also we discussed how Bigram captures short phrases but may miss individual word signals. So why not combine them? That's exactly what we do in Unigram plus Bigram. We take both individual words and word pairs together to capture both the meaning of each word and the phrases or combinations they form. Let's use the same two sentences again. This laptop is good. This laptop is not good. Now, if we combine Unigram plus Bigram, we split the sentence like this. As we discussed earlier, we are taking one word and two words at a time from the sentence to form a Unigram plus Bigram that you can see here. Combination of two, right? Unigram plus Bigram. And this is Unigram plus Bigram for our sentence 1. This is Unigram plus Bigram for our sentence 2. Now, as usual, from the sentences, we collect all unique unigrams and bigrams to form our vocabulary, which means the features generated by this combination, Unigram plus Bigram, that you can see here. Now, let's form bag of words matrix. Bag of Unigram plus Bigram means bag of 1 gram plus 2 gram, right? This means we go sentence by sentence and count how many times each Unigram plus Bigram appears. And this is our bag of words matrix for Unigram plus Bigram. Now you can see it is combination of Unigram plus Bigram. What's the benefit? With this combination, we get individual words signals like not, that you can see here. Phrase understanding like not good, right? So now even if a word like not appears rarely, it still contributes meaning. This is especially useful in sentiment analysis where not good and good mean opposite things. Now let me show you how to implement Unigram plus Bigram combination using Python and sklearn. Now let's move back. So again, we are using exactly same code that we have used for Unigram, Bigram and Trigram. Now let's change the code so we can combine Unigram plus Bigram. Again, as usual, we are interested in this particular parameter. But now, please look here carefully. because we are going to implement Unigram plus Bigram. For that, here we have to write 1 and here is 2, which is combination of Unigram plus Bigram. If we write here 3, it's a combination of Unigram plus Bigram plus Trigram. Now, if we want to combine Bigram and Trigram, we have to write like this, 2, 3. Hope all of you are clear with this, right? 1, 1, Unigram. 2, 2, Bigram. 3, 3, Trigram. Same way you can move forward with different values, 4, 4 for 4 gram. But if you want to combine like Unigram plus Bigram, we have to write like this, 1, 2, which is combination of Unigram plus Bigram. Here, the combination of Unigram plus Bigram plus Trigram. If we write here 2, it's a combination of Bigram plus Trigram. Hope all of you are clear with this, right? Please try to perform this and write the cosine similarity in the comment section of this video. But currently, let's use the combination of Unigram plus Bigram. Again, let's execute all the cells from top to bottom. Now, cosine similarity is around 0.76. Again, let's copy and paste it over here. So this similarity is more accurate now. Not too high like Unigram and not too strict like Trigram. It finds a nice balance between word presence and context, right? So as per our requirement, we have to experiment with Unigram, Bigram, Trigram and different combinations like this. I hope all of you are clear with how to implement Unigram, Bigram, Trigram and combinations using Python and sklearn. Now let's back to our presentation. Now let's discuss some of the advantages of using this combination, Unigram plus Bigram. So as you know, it combines both single words and phrases. It captures meaning better than Unigram alone. It doesn't explode vocabulary like Trigram. And here are some limitations. Slightly more memory is required, right? That is obvious because we are combining Unigram plus Bigram, different combinations, and still does not catch longer expressions, but works great in most cases. Now I am sure all of you are clear with Unigram, Bigram, Trigram, and how to use different combinations. And at the last, please remember OOV problem still exists in n-grams out of vocabulary. What happens if word is not part of a vocabulary during prediction? It still exists. We will discuss more advanced techniques in upcoming videos. Hope all of you are clear with this, right? Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.